Hello students, welcome back. Let us take a look at the summary of chapter 14, statistics. So we'll start with data. Now at the very start of the chapter, we learnt about information that can be collected through or can be gained through various formats, sources or media. Now of this information, only the information, facts or figures that are collected with a definite purpose is known as data. Then using data, we moved on to statistics, which is an area of study dealing with the collection, organization, analysis and interpretation of data. And now for learning statistics, we learned about representation of data into two formats. One was tabular format and one was graphical format. So what is tabular format? Representing your data in the form of tables, whereas graphical format, as the name suggests, it's about representing your data in the form of pictures, right? So these pictures are not just simple cartoon pictures, but they are of different types, which we will take a look at. So tabular format, we learnt about frequency distribution tables, right? So I'll just write FDT for frequency distribution table, and we learnt about two frequency distribution tables, which was grouped frequency distribution table. So grouped FDT, and the other one was ungrouped FDT. So an example of ungrouped frequency distribution table would be that of blood groups, the simplest example, wherein you cannot club your data into different, you can club your data only under one single category. You cannot have a range of categories to sort out your data or to represent your data. For example, the various blood groups that are there are A, B, AB, O, right? You cannot write it as a range from blood group A to B, B to AB, B to O and so on. So here you will have ungrouped frequency distribution table where there will be single categories A. Let's say there are 3 patients who have this blood group. There are 4 patients who have this blood group. Then there are 15 patients who have the blood group AB, and there is just 1 patient who has the blood group O. So here this will help you find out that O is the rarest blood group, whereas AB is the most frequent blood group. So this was about ungrouped frequency distribution table. Now what about group frequency distribution table? Again, this is a tabular format for representation of data, wherein you can enlist all your data depending upon ranges of the categories. For example, if you are talking about the scores of student, okay, and the frequency. So from score 1 to 10, so let's say there are scores, the total marks are out of 100, we will list down the various scores. So 10 to 20, 20 to 30, 30 to 40, up to 90 to 100. And there are about 30 students in the class. So you can say 2 students secured marks between 1 to 10, then 5 students secured marks between 10 to 20, and 18 students secured marks between 20 to 30, then 6 students secured marks between 30 to 40 and so on until you get the total, that is the total of the frequency as 30 students, right? So this is just a brief description of your grouped and ungrouped frequency distribution table, wherein these are known as the class intervals. The first one in each class interval is known as the lower limit, whereas the second entry is known as the upper limit. The difference in the lower limit and upper limit of each class is known as the class size, alright. And the class intervals are also known as class. Moving on, let us take a look at what was graphical format. In graphical format, we learned about the most simplest of all, bar graphs. We learnt about histograms, and we learnt about frequency polygons. So bar graphs were nothing but they were representing all your data in the grouped or ungrouped frequency distribution table using the coordinate axis. So this, suppose let's say this is your coordinate axis with O as the origin, wherein your x and y axis meet, and you have all the variables listed on the x axis and their values on the y axis, and then you plot bars of uniform width with uniform distance between them. Uniform width, but the length could vary because the frequency. So the frequency is always listed on the y axis, whereas the variables are listed on the x axis, right? So this was about bar graphs. Then what was histograms? And bar graphs are usually used to denote ungrouped frequency distribution tables. Then what about histograms? Histograms are again used to represent your frequency distribution table, but for these your classes have to be continuous, and it is used to represent only grouped frequency distribution table. Here all your bars will be connected to each other. So first of all, in histograms you can have bars with uniform width or variable width. Why uniform and why variable? So let's see. First of all, in histogram it's very important that the class interval should be continuous. And the second most important thing is we need to know whether we have bars of uniform width or variable width. So what does this mean, bars of uniform width or variable width? In histograms, the area of the bars are directly proportional to the frequency. So if the widths are equal, if you get, let's say this was your histogram, here you have bars of equal width, right? They both look equal, the width is the same. So here the lengths become proportional to the frequency. See, the area is proportional to the frequency in histograms. So area is nothing but area of rectangle, which is length into width or length into breadth. So length into width is proportional to the frequency. Also we plot the frequency over here on the y-axis, right? So now if I say that this is constant throughout, that is the width is the same throughout, then the length becomes proportional to the frequency. So whatever length you give to your bars, that will correspond to the frequency. But in case you have a histogram with variable width, then the width is not constant throughout, and then you will have to adjust the frequency to, you will have to adjust the frequency of the given group frequency distribution table, that, and then will it correspond to the length of the bars. So here we need to, in ungrouped, just one moment. In variable width, you will have to adjust the frequency of the bars of the given data. Because of the given data, we are going to draw bars, right? Then comes frequency polygons. Now frequency polygons can be drawn using either the histogram or by using the class intervals, right? How do we draw frequency polygons using the histogram? We are going to take the midpoints of each of the bars of the histogram. So I will take the midpoints using a different colored chalk. So let's say this is the midpoint, this is the midpoint, this is the midpoint, and this is the midpoint out here. And just the equal length here on the extreme towards the left, and an equal length or class interval to the extreme right, and I am going to connect these points that I mark. This is going to give me frequency polygon. So this was frequency polygon using histogram. The other method to draw a frequency polygon is to use the class interval, wherein we would need the class marks, which is going to, the class mark is nothing but the midpoint of each of the histogram. And how can this be found out? Using the formula of upper limit of a class interval plus lower limit of class interval divided by 2. This will give you the class mark. Then you are going to take the coordinate of frequency and class mark of that particular class, and you are going to plot it on the graph sheet. So you will not get these histograms, you will just get these coordinates, and you can draw your frequency polygon. So you will directly start to plot. Suppose let's say the coordinates that you find are like this. So you can draw your frequency polygons like this, right? Now what are frequency polygons? In which cases are they usually used? Frequency polygons are usually drawn when we need to compare the observations of the same categories. For example, if there are two teams who are playing soccer or any match, then you need to compare how fair they performed. Then you can have two frequency polygons plotted on the same graph sheet. Let's say this is for team A. I'll give it a name. A, B, C, D, E and F. So A, B, C, D, E, F represents the frequency polygon of team A. Now I will draw another frequency polygon to represent the performance of team B. So I'll give it another name, M, N, P, Q. So A, M, N, P, Q, F represents the frequency polygon for team B. This will help us compare how the scoring of the two teams, right? Now moving on to measure of central tendency. So why do we learn about measure of central tendency? Because I hope you remember I asked you a question when we started with this topic. Is studying of the entire data essential to understand what the data is all about, or to gather all information about the data, or just a few representatives of it are enough? Which is why the mean, median and mode, they came into picture, which are nothing but representatives of central tendency. But also to note that they are not essential, they cannot be used in almost all the cases, and sometimes we will be needing extra data. So let's see what is mean. Mean is nothing but average. It is denoted by x bar or any variable with a bar, and it is nothing but sum of all observations upon total number of observations. It can also, you can also find the mean for the given data using an ungrouped frequency distribution table, and the formula that can be used is summation I is equal to 1 up to n fi xi upon summation I is equal to 1 up to n fi. So what is each of this? The variables we are referring to, I'll explain it to you. Fi is going to be nothing but the frequency corresponding to this entry or this category into your ungrouped frequency distribution table. So let's say, I'll give you a very small example. If I have a frequency, ungrouped frequency distribution table wherein I have a category marks, alright, and marks could be 1 to 10. So 1, 2, 3, 4, 5, 6 and so on up to 10. Okay, so let me just take marks from 1 to 5, and if I give the frequency that is 3 students secured 1 mark, 7 students secured 2 marks, then 1 student secured 3 marks, 4 students secured 4 marks and 5 students secured, there are 8 students who secured 5 marks, right? So when you total these up, you will get the total frequency or the total number of students that are present. So 8 plus 4, 12, plus 1, 13, plus 7, 20, plus 3, 23. So 23 are the total number of students. So now I is equal to 1 up to n. I is going to be the individual entries. So 1, 2, 3, 4, 5. So I will go from 1 to n, which is 5. Okay, and it will keep going into a loop. So from 1 to 5, you're going to sum up what? You're going to sum up fi xi. That means f1 x1. So f1 x1 will be 3 into 1. This is fi xi. So 3 into 1, 3, 7 2s are 14, then 1 3s are 3, 4 4s are 16 and 5 8s are 40. And then you're going to take a sum of all this. So what is the sum of this entire thing, you have 6, 7, 8, 9, 10, 13 plus 3, 16, and then you have 4, 5, 6, 7, 76. So summation of I is equal to 1 up to n. So first of all, we will rewrite this as I is equal to 1 up to, how many entries do we have? 5 entries. What is the total of Fi xi? It is 76. So we'll write it as Fi xi upon summation I is equal to 1 up to 5 Fi. So what is this going to be equal to? The numerator will be equal to 76. And now we are just taking Fi in the denominator up to 8. So up to 5 entries. We have 1, 2, 3, 4, 5 entries. So what's the total? You have 23. So this is going to be your mean. 76 upon 23. You can calculate it further. I'm not really calculating it for you right now, but I hope you've understood what exactly average is referring to or mean is referring to. Moving on to the other method, which is median. So median is a value which gives you which divides the observations into exactly 2 equal parts. Now the observations that you can have, the number of observations that you can have could be even or odd. So if you have odd number of observation, the median is given by n plus 1 upon 2th observation. Right? This is in case of odd number of observations. And if you have even number of observations, then the median is given by n upon 2th observation, the mean of n upon 2th observation plus n upon 2 plus 1th observation. This is in the case of even number of observations. So let's say you have 7 observations. So what would be the median? The median would be 7 plus 1 upon 2, which is 8 upon 2, which is the 4th observation. So for the 4th observation would be your median. But it's very important to find the median that you arrange your data or the observation into either ascending or descending order. So if you're taking, once you've arranged your data into ascending or descending order and you found this value which was the 4th observation, you can go counting about towards the left or from the right and find the observation which would be the median. Now when you have an even number of observations, let's say you have 10 observations, right? So this would be 10 upon 2th observation, which would be 5 plus 5 upon 2 plus 1, which is going to, 10 upon 2 plus 1, which would be 5 plus 1, which is 6. So the mean of the 5th and 6th observation would give you the median. Again, your data needs to be arranged either in ascending and descending order. And mode is what? Mode is going to be the observation with maximum frequency. Which means nothing but if you have many observations, then the observation that is repeating the most often is going to be the mode. So for example, if I have numbers such as 4, 3, 3, 3, 7, 9, 3, 2, 1, 7 and 3. So now in order to find the mode, what we are going to do is arrange all these observations into either ascending or descending order and write down the number which is repeated the most often, because mode is the observation with maximum frequency. So here I know that I have given the data and 3 is repeating the most number of times. So my mode is going to be 3, because it's repeating the most number of times. Why? Because I have 1, 2, 3, 4 and 5. 3 is repeating 5 times and there's another number 7 that is repeating 2 times if you notice, but the number that repeats the often becomes the mode. And the last point that I would like to make with respect to measures of central tendency. So in central tendency we have mean, median and mode. Mean or the average gets affected by extreme values present in your data. So for example, if you have small or large amount of data with a lot of variation, wherein one of the data is 2, then you have 88, then you have 90, 100 and let's say 27. You see there's a lot of variation between 2 and 100, 27, 100. or 2 and 90, 2 and 88. So if you try to take the average of this data, then it wouldn't really be very effective for measures of central tendency. Whereas the median and mode, they do not get affected by the extremities in data, that is extreme variation in data. So in such cases, when you have a lot of variation or difference in the smallest and the largest values present in your data, then the most effective measures of central tendency would be median and mode. So this was about the summary of chapter 14 statistics. I hope you enjoyed doing this chapter as much as I did. Please take a note. Thank you for watching this video.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.